If this video clip doesn't say it, nothing will. Red Dead 2 is one of the most graphically intensive games on GPUs in recent history. Just look at it. That horse has at least 20, maybe even 25 polygons. Amazing. After benchmarking CPUs and GPUs in Red Dead Redemption 2, check the channel for that, we're now back to deep dive on the many graphics options. There are dozens of them in the PC release of the game. We'll have a separate graphics optimization guide coming up for benchmarks, but before that, we need to fully explain what each of these settings does. We'll also point out a few of the more interesting graphics techniques that Rockstar has implemented in Red Dead 2. Andrew, our lead video editor and a 3D artist, has assisted in putting together explanations and research with Unreal Engine and other examples, and Patrick has also assisted in exploring the game and its graphics. Before that, this video is brought to you by the Gigabyte Z390 Master motherboard. If you're building a high-end gaming PC soon, consider the Z390 Master for its strong VRM for overclocking, properly finned VRM heatsink for better cooling than most, and inclusion of RGB LEDs in key areas. Learn more at the Z390 Master by Gigabyte at the link in the description below. We're going to get right into this one and talk about the graphics settings in Red Dead Redemption 2 for the PC. So this will include some comparisons, for example, low versus ultra, to just really illustrate what's happening, what's changing with the setting in question. We'll be talking about some of the more uncertain ones, some of the ones that haven't been exposed before, or at least named in this way before in games, like, for example, unlocked volumetric Raymarch Resolution. That's one of them. Parallax Occlusion Mapping quality, volumetrics information, and we'll also go over some of the older basics that have been around for ages, like LOD, just to catch everyone up, and talk about how it is used or what changes in Red Dead 2 when you toggle those different settings. So let's get into it. We're not covering literally every single graphics option in the game because a lot of them are extremely obvious what they do. Like texture quality, for example, pretty simple. It changes the effective texture resolution of the textures in the game and is more VRAM intensive than really any other resource, so that's what matters there. We won't talk about that one. I kind of just did talk about that one, but we won't talk about other ones like that. Let's dive into the more complex ones and talk through the unique settings for Red Dead Redemption 2 on PC. Parallax Occlusion Mapping quality is another setting that probably needs a definition. This is a self-explanatory setting, but that doesn't really help given that each word in the phrase has a specific meaning in computer graphics. Parallax Occlusion Mapping and its quality increases the level of perceived depth on surfaces using parallax occlusion, or a technique used to generate depth on an otherwise flat surface. Parallax occlusion is also not new, but the mapping quality in this setting refers to how detailed the parallax occlusion implementation will be. When we looked around for examples from outside of Red Dead Redemption 2, just to help explain this, this was one of the better ones. A rug, for instance, could be left as flat geometry with a texture that fakes depth, like with fibers, for example, pursuant to the camera perspective. Instead of flooding hardware with additional geometry processing, parallax occlusion mapping fakes added definition and fakes added geometry at a lower performance cost. Another example would be maybe a brick wall, where a flat wall could be used rather than a real handcrafted set of geometry and bricks, but depth can still be faked, and those bricks at different depths can be faked by displacing the texture coordinates. In Red Dead 2, an example of deployment for parallax occlusion mapping would be the forest floor, where a flat-ish texture is used, but this graphics trick can make it appear as if things like pine cones and sticks are separate geometry, but they aren't. It's just a good trick. It cost way too much in cycles and effort to make all of that individual geometry on the forest floor, but the effect can be faked at the right viewing angles with parallax occlusion mapping. This might sound an awful lot like tessellation in some ways. The end result of the effect is usually difficult to distinguish from the end result of tessellation, but the primary difference is that parallax occlusion does not add any additional geometry, nor is it able to affect the silhouette of the mesh, but it's usually much less resource intensive than tessellation. Tessellation is another big one. Red Dead 2 has a tessellation quality option, which affects the quality and definition of ground mutations and deformities of things like snow and mud imprints. Tessellation is the process of subdividing surface geometry and manipulating its coordinates to create more depth. Unlike parallax occlusion mapping, tessellation actually adds geometry through this subdivision process and becomes more computationally demanding on the geometry pipeline of GPUs. The ground is relatively flat geometry that is then subdivided and deformed to create snow on top of that base geometry. But despite the tessellated snow on top of the ground, the collision model remains in the same place as the base geometry collision model. This allows the player to remain in the correct vertical position while walking through the snow, so instead of standing on top of the snow, for example, which then deforms or destroys the snow tessellation to create footprints or item imprints as things are dropped or rolled in it. A typical way to do this in games would be to use a render target to draw a white and black displacement mask, something we found another video to demonstrate, and use a top-down camera to track the player or items on the terrain. In this instance, snow deformation and the tessellated terrain will use a white and black mask to determine the offset from 1 to 0, i.e. from white to black, and with a gradient between, 0.5 for example. As snowfall continues at X rate over time, the rate at which the mask offset changes between 0 and 1 will accelerate or decelerate or stop. Snowfall and snow accumulation are two separate events in the game as it appears on the ground versus as it falls from the sky and appears on your screen. The game doesn't really know anything about an amount or a volume of snow falling from the sky. All it knows is a rate at which the mask will move from black to white, indicating the ground being filled back in with snow where your footprints may have appeared over time, which is a pretty cool effect and obviously hasn't been in games for that long, at least at a quality level like this. Higher tessellation settings will improve perceived depth and geometric complexity of things like brick walls and roads, and will affect the snow deformity and complexity of accumulated snow on the ground as well. Lower settings will improve performance significantly on some hardware. As for the player's clothing, that's not related to tessellation, but it's worth talking about this since it relates to snow, which is our current topic. The player's clothes will appear to accumulate snow over time, or will bond with snow if the player falls or rolls around on the ground. We think this is probably done by using something like alpha textures that are then blended into the coat texture. So you have different snow alpha textures that are applied to and blended into the coat texture, rather than just using an opacity change where the whole snow texture would change its intensity. It is a blended effect. We should probably talk about unlocked volumetric Raymarch resolution early in this content. This one is a unique setting to Red Dead 2 on PC, so it's worth delving into as soon as we can. Raymarch resolution in Red Dead Redemption 2 and its setting is what dictates the amount of steps calculated on each ray line cast into the determined volumetric area. Don't think of this like NVIDIA's RTX and their version of ray tracing, but instead like a line that's used to scout a volume for establishing how far each point in 3D space is relative to the overall volumetric area that it's measuring. For example, determining where the edge of the cloud is, where the middle of the cloud is, and where the opposite side of the cloud is would be versions of this. So this information is needed to know how much light should be passing through any given 3D point on the cloud, where the denser area would allow less light through than the edges. This is a setting strictly relegated to cloud quality in the game. Raymarching is an intersection check wherein points along the ray are tested for collision or intersection with another object, usually geometry, although it's used here for volumetrics, which are specifically non-polygon items like clouds, smoke, things like that. The ray is checked in steps that are typically at fixed intervals, although we're not sure how Red Dead 2 handles its stepping precisely. It's in the code somewhere. Relating to clouds, Raymarching would be useful for determining things like light direction, light color, and self-shadowing. We'll talk about performance in a different content piece, but this is something that should only impact outdoors performance unless Rockstar either implemented it really poorly, which is definitely within their capabilities, or used it on other volumes that we don't know about, like maybe fog. But as far as we know, this should only ever affect clouds. We should next explain full resolution screen space ambient occlusion. This has a lot of baked-in terminology, so it's kind of confusing to look at. Ambient occlusion is already well-defined and probably doesn't need much of a deep dive here, but we can use Unreal Engine to create some on-the-fly examples of ambient occlusion before explaining this specific setting in Red Dead 2. In this tech demo, Andrew will use Unreal Engine to quickly scale ambient occlusion to dramatize what it does intentionally. We're just trying to make it obvious by jumping to the extremes, not make it look good. Ambient occlusion is a phenomenon in which objects in close proximity will occlude light from each other's surfaces. Ambient occlusion, or AO, is a lighting model in computer graphics and rendering that evaluates pixel brightness as the pixel relates to objects in the vicinity. The on-screen demonstration should help illustrate all of this. AO is not anything new, and neither is Screen Space Ambient Occlusion, or SSAO. But despite not being new, this full resolution screen space ambient occlusion setting needs some more definition. So screen space ambient occlusion is a technique where rather than using ray tracing to calculate surface-to-surface proximity in 3D space, the code will instead approximate by calculating the pixel depth buffer from the camera's perspective. The phrase depth buffer is primarily a means of communicating the coordinate depth in 3D space by using a two-dimensional array. As for Red Dead and the Red Dead graphics setting, full resolution SSAO disabled would specifically refer to the pixel depth buffer being calculated at a lower resolution than the game's configured resolution, hence full resolution SSAO. Enabling this option increases the resolution at which the pixel depth buffer is calculated and equalize it with your configured game resolution, i.e. 4K, 1440p, 1080p. Volumetrics next. Red Dead 2 has a lot of volumetric settings, including near volumetric resolution, far volumetric resolution, and volumetric lighting quality, alongside the already defined volumetric raymarching. These settings are fairly self-explanatory. Near volumetric resolution increases the quality of volumetrics closer to the camera, far increases or decreases the quality in the distance, and volumetric lighting quality increases overall volumetric fidelity. As for what volumetrics are, we captured a few examples from gameplay to help. Volumetrics include things like smoke, fire, explosions, and fog, among other examples that are not geometry-based. Smoke and other in-game volumetrics are dynamic and don't appear to follow a fixed path, rather than using older techniques like stacked alpha textures or textures that follow the camera perspective, like you may have seen in some games where you have smoke grenades, for example. The engine instead uses math on the GPU to calculate a body with volume. Volumetrics are more computationally expensive, but a lot more believable than alpha textures and textures that just follow your perspective. The game also makes heavy use of fog, which is another volumetric effect. Red Dead 2 draws a lot of volumetric lighting with its fog, like the colloquial God rays, also known as crepuscular rays, that are beams cast through the volume container. These effects are partly controlled by the lighting settings and partly controlled by the volumetric settings, mostly distance at which they remain visible or higher resolution. Level of detail is next. This is an easy concept to explain and will help define a couple of graphic settings in Red Dead 2. Geometry level of detail and grass level of detail are both adjustable by a multi-tick slider. Geometry LOD can be adjusted in 5 ticks, and grass LOD can be adjusted in 10 ticks. Higher geometry LOD will allow for longer draw distances of the full complex geometry. As distance to the object increases, the mesh quality may decrease to reduce load on the system. A lamppost or a wagon in Red Dead 2, for example, will show greater definition at farther distances with higher LOD settings, but at significant performance cost in geometrically complex areas, like St. Denis in the game. Geometry loads both the GPU and CPU and APIs like DirectX 11, but Vulkan and DX12 both reduce draw calls on the CPU and make them more of a GPU task. Reducing this setting would help if experiencing poor performance in geometrically dense areas. As for grass LOD, that one's pretty simple. The draw distance of grass as a whole is lessened with lower LOD settings, so you'll see more grass pop out as distance is gained with a lower setting for this option. Rockstar says that, quote, Ultra will also enable grass shadows, but the company doesn't actually label this option with low, medium, high, ultra terminology, and instead uses a slider. We're assuming it's in position 10, but we're not fully sure here. They'll probably change it eventually. Rockstar's menu has a few confusing inconsistencies like this one, though. Another LOD setting is the tree quality option. This option adjusts the distance at which LOD scaling takes place for all plants in the game. Typically, objects like plants will have multiple levels of detail that will be chosen based on your distance from them. So they are preset LODs for the objects. Close-up distances should be mostly unaffected by this setting, showing plants at the highest quality possible, but mid-range or longer distances will follow this setting's configuration for LOD. Water settings are some of the most intensive in most games. For Red Dead 2, we have options of water physics quality, water reflection quality, and water refraction quality. In the very least, the level of granularity provided by Rockstar is somewhat unrivaled. Most games don't allow tuning of both reflections and refractions individually. That seems a bit crazy, not in a bad way, just in doing more than needed way. Water physics quality is the one that will most likely affect your game performance. This setting changes the water simulation quality, like determining how water responds to interaction with boats, horses, and other objects. With higher water physics quality, we notice that water warps around the nose of canoes and boats, that it warps around paddles and is displaced by them when entering the water, and that it flows around and physically engages with things like rocks and the rapids. As for reflection and refraction quality, that's just plain English, so no need to explain those settings. There are a few different types of anti-aliasing settings in Red Dead Redemption 2. Settings include TAA, FXAA, MSAA, and reflection MSAA, and none of these are new. They've all been around a long time. We'll start with the easier ones. Reflection MSAA adjusts the amount of samples per pixel for reflections, so that's the sample count for objects specifically in screen space reflections. Screen space reflections, if you're not aware, are reflections like those in water that use existing screen data. We provided examples of this previously in Battlefield 5 testing, and I've shown it in Far Cry 5's built-in benchmark as well. Screen space reflections are common and save resources by only calculating reflections for what's already on the screen. In Battlefield 5, RTX had a leg up here because it could calculate reflections for out-of-frame objects, whereas screen space is unaware of how those objects would reflect in water that's actually within the player's view, because those objects don't exist also in the player's current view. So the trade-off was performance, but that's just an example. Higher samples per pixel will improve the quality of the reflection by decreasing aliasing at the edges, making for smoother transitions between pixel values and more accurate edge colors. The downside is that you're effectively doing work equivalent to re-rendering the sampled area additional times, which increases load significantly when compared to other graphics options in the game. MSAA is also available game-wide and is the probably most effective of these AA options, but also the most resource-intensive. Sampling every pixel multiple times, like 4-tap or 8-tap or whatever, will drastically increase load on the GPU. TAA is temporal anti-aliasing, another old form of AA that's been around a while. As is given away by the name, temporal anti-aliasing is calculated against time, so temporally, which is supposed to reduce the disconnect between high-speed object movement and rate at which the scene is sampled. Some people may dislike how TAA has a tendency to create a ghosting-like appearance that's especially noticeable at lower game resolutions. TAA performance impact, though, on the upside, is often, in most games, relatively minimal. FXAA is the last one we'll talk about. It's also ancient, and is probably most famous for its use in Skyrim, although it had other implementations before that. Fast approximate anti-aliasing is extremely lightweight and has functionally zero impact to performance in most games because FXAA doesn't rely on geometry to do its calculations. FXAA smooths jagged edges without mathematically analyzing the base 3D model, but instead analyzes the output to the screen. So it's a little less accurate, but it costs less to run. FXAA is most often criticized for its reduction in texture sharpness and for failing to really provide any meaningful value for a lot of players. There are a lot of other settings here too, and we're not going to talk about every single one of them because a good portion of the maybe 30 or so graphics settings in the game are self-explanatory. Some of the minor ones or easy to understand ones are really somewhat standard. We'll breeze through a couple of these that require less explanation though. Decal quality changes the texture resolution of decals used on surfaces. Like in all other games, common examples of a decal would include blood spatter, bullet holes in characters or buildings or objects, or other surface level, non-mesh, non-object changes that are applied from things like damage or collisions with textures. Fur quality changes the perceived depth of fur, like deer or clothing fur, and it goes mostly unused since fur is not always in the game, so this won't impact your performance, or shouldn't anyway, if there's no fur on the screen. Most of the other options are pretty easy. So soft shadows softens the edges of the shadows. It costs more resources to do, but you don't get those really hard to find shadow lines, and instead get something a bit more accurate to life, where it softens as it gets out towards the boundary of the shadow. Lawn shadows is another one that's self-explanatory. If you turn it on as for specific times of day, like night or early morning, where the sun is casting light from a relatively low point on the horizon through, say, trees, you'll get a longer shadow drawn with it on than off. It's a bit more resource intensive, but it's a small feature that's added to the game. And that should pretty much cover everything that's in any way confusing or unknown, and even some of the more common settings like anti-aliasing, just as a recap for everyone. So that'll wrap it for this explanation, the graphics deep dive as it is. Unfortunately, our understanding is that currently roughly about 50% of people who responded to a recent poll, it was about 5,000 people responded. It will bias towards the negative, of course, but still 50% is a very big number. 50% to the Reddit poll were unable to even launch or play the game. So how useful this is probably contingent on if Rockstar ever gets its stuff together, to phrase it nicely, and does what they should have done to start with. So we can't really overstate just how atrocious this launch was by Rockstar. They have massive launcher issues. That launcher's not old. It hasn't really been tested. And they forced it through to get it out in time for Red Dead. They have issues with the game itself, like that silly video clip we found from another user at the beginning of this video. There are issues with, for example, the screen just being purple, maybe related to drivers, but seems to happen more frequently with Red Dead than we typically see, and a lot of crashing problems. And also support, we just submitted a support ticket ourselves, and the estimated response time is 60 hours for live chat. That's not live chat anymore. It's 48 hours for email too. So clearly Rockstar has done a horrible job at launching this game, and it has all manner of problems. But anyway, that's a discussion for another time. Hopefully this graphics analysis helped you out, and if you're not playing the game, at the very least, it should have maybe brought some new terminology into your lexicon for use in gaming. Subscribe for more of this. Go to store.gamersnexus.net to support us directly, like by buying one of our shirts. This is the Blueprint shirt, or one of our mod mats, toolkits, or GPU anatomy posters. You can also go to patreon.com/gamersnexus to catch some of our behind-the-scenes videos and bonuses, like the recent one with Wendell from Level 1 Techs. So thanks for watching. I'll see you all next time.